Running an AI model locally on your own machine offers absolute privacy, removes monthly subscription fees, and gives you total control over the software. However, the open source landscape is crowded. Thousands of models are available for download today, and choosing between them can feel like a moving target. These models are defined by their parameter counts. When you see labels like 7B, 13B, or 70B, you're looking at the number of neural connections, in billions, that the model uses to process information. Your hardware acts as the final authority on which models you can actually use. While anyone can download a large model, loading and running it requires specific physical memory and processing power. Selecting a model is a practical negotiation with your hardware limits. You have to identify how much cognitive depth your machine can afford to support. Higher parameter counts allow for more complex reasoning. As the neural network grows, the model becomes more reliable at tracking variables across long, multi-step logical chains. We can organize the current open-source landscape into 3 main tiers. These levels determine the model's complexity and the equipment required to host it. The base tier, ranging from 1B to 8B parameters, handles general-purpose tasks. These models are designed to run on the standard laptops and PCs most users already own. The 13B to 34B range provides professional-grade logic, but it requires a high-end workstation with a dedicated graphics card and significant video RAM. At the peak, models with 70 billion parameters and above offer expert-level analysis. Operating these requires industrial-grade server clusters. Climbing this pyramid improves the model's intelligence, but it forces a trade. You will see slower response times and much higher hardware costs. The baseline tier includes 7B and 8B models. These require between 8 and 16 gigabytes of RAM to function effectively on a consumer-grade PC. On a mid-range GPU, these models are incredibly efficient, generating 20 to 80 tokens per second, faster than most people read. This speed makes them effective for real-time chat, creative writing, and basic coding assistance. However, these smaller models have clear limits. They struggle with complex logic and may lose track of specific details when a conversation becomes too long or technical. If your priority is a fast, responsive assistant for everyday tasks, the 7B tier is the most practical starting point. For professional work, you need the reliable in-context learning and advanced problem-solving found in the middle tier. This level requires a significant hardware upgrade. You'll need 24 to 48 gigabytes of VRAM, which typically places the total workstation cost in the $3,000 to $5,000 range. The benefit is performing nuanced professional writing and solving complex bugs that confuse smaller models. But the cost is speed. Response times drop to 10 or 40 tokens per second, creating a noticeable delay. For developers and researchers, the question is whether the deeper reasoning justifies the higher price tag and the slower performance. Models in the 70B range represent the ceiling of local performance. They possess the knowledge density required for expert-level analysis across specialized fields like medicine, law, or engineering. The infrastructure required to run these models is massive, involving high levels of physical power consumption and heat management. To run a 70B model, you need at least 64 to 128 gigabytes of RAM, usually spread across multiple high-end enterprise-grade GPUs. Without a $10,000 server setup, these models become unusable. Response times can drop to a crawl, producing only a few words per minute. Firm. Most individual users should avoid the 70B tier. It is for commercial applications that require absolute accuracy and have the budget to support it. You can maximize your current hardware by using a technique called quantization. Quantization mathematically compresses a model by rounding down the precision of its weights. This reduces the file size so it can fit into much smaller memory pools. This compression reduces memory requirements by 75%, changing the relationship between capability and cost. It allows you to run a larger, smarter model on hardware normally too weak to load it. The trade-off is a slight loss in reasoning precision. The model might become less accurate in its logic, but the difference is usually acceptable for most tasks. Quantization is a vital tool for hobbyists, allowing them to use professional-grade logic standard consumer hardware. We can now map these tiers to your specific situation to find the right deployment for your machine. The first decision point is your hardware budget. If your budget is under 1500 and you need writing or chat help, focus on 7B to 8B models. If you invest over 3000 for complex coding, target the 13B to 34B tier. Only those with enterprise-level budgets and commercial accuracy requirements should consider the 7DB models. Successful local AI deployment depends on aligning your machine's memory capacity with the specific cognitive depth your project required. The most effective approach is to start with the smallest model that might work. You can always scale up if the model fails to meet your needs. Avoid the mistake of building an expensive, heavy workstation for simple tasks that a small model can handle instantly. Before buying any new hardware, test your current machine using highly quantized versions of larger models to see how they perform. A well-optimized workflow runs perfectly smoothly because it strictly matches the model's weight to the hardware's actual strength. A 7B model is a specialized tool for high-speed, lean environments. It performs its intended tasks faster and more efficiently than its larger counterparts. Armed with a clear understanding of your hardware's limits, you can now confidently select and deploy the local AI that fits your needs.